Hi guys, in this tutorial I'm going to solve question number 6, Mechanics 1 Jan 2019 edX syllabus. Two particles A and B have mass m and 3m are shown. So if you look at the horizontal one, for particle A it's horizontal, so it's better to show the resolving forces, which mass and weight acting down and normal reaction acting up. It's a particle, so we deal with it as a point, where is the center, the mass or the weight acting at the center. So here, weight, mg, and normal reaction. For particle B, how to show the resolving forces components like this. This will be mg sine alpha, mg sine alpha, but mass here is 3. Don't forget to write 3mg sine alpha and 3mg cosine alpha, and normal reaction for B, normal reaction for A. Now, continue to particles A and B have mass m and 3m respectively by the same order. Look at A is m and B is 3m. The particles are attached to the end of the light in extensible string. The particle A is held at rest on a rough horizontal table. The coefficient of friction between the particle A and the table is 1/5. Mu here is 1/5. Mu is 1/5. The string lies along the table and passing over a smooth light pulley that is fixed at the edge of the table. Particle B is at rest on a rough plane that inclined at an angle alpha, where is tan alpha given. It's better to show the exact value of alpha. Tan is opposite over adjacent. Apply Pythagoras to get 5. So sine alpha is equal to 4/5. Cosine alpha is equal to 3/5. So this answer is 0.8. This answer is 0.6. The coefficient of friction between particle B and the inclined plane is 1/3. The coefficient of friction here is 1/3. The string lies in a vertical plane that contains the pulley and the line of the greatest slope of inclined plane. The system is released from rest with the string is taut and B slides down. This is given direction of motion. The system is released from rest with the string taut and B slides down the inclined plane. Given that A does not reach the pulley, find the tension in the string. It's 11 marks. Don't forget, for any question, whatever in moving or in equilibrium, start to show all the resolving forces, start to write all the equations, whatever in equilibrium or in motion, then start to solve simultaneously. I will start first with particle A. Particle A move in this direction. Under what? Under tension. So we have a frictional force in opposite direction of tendency of motion. So when the particle moves to the left, so the friction force appears to the right. So now I will write 3 equations. Second law of Newton, all the forces in direction of motion minus all the forces in opposite direction is equal to MA. So tension minus friction force is equal to MA. Second equation, all the forces acting up is equal forces acting down. Third equation, because in motion, so the friction force now is maximum is equal to mu r. By the same way for particle B. For particle B, move down because of what? Which is in the force in direction of motion. Mg sine alpha minus tension minus frictional force is equal to MA. What else? R is equal to mg cosine alpha. What else? Frictional force is equal to mu r. Let's start now to substitute in each equation. Back again to the particle A. If we start from this equation to find the R is mg. Is the mass is m? Yes. So m times g, this is the final answer. Go for the frictional force. Mu, the coefficient of friction is 1/5. So 1/5 mg. Now substitute in this equation. Tension minus frictional force, which is 5th mg, is equal m times A. Now leave this equation. For the second equation, we'll start by the same way from here. R is, the mass is 3m times g times cosine alpha, which is 0.6. And frictional force now is equal to, the coefficient of friction is third, it's given here. The coefficient of friction for inclined plane is third. So third, R is 3mg times 0.6. If we simplify, the answer here is 0.5 mg. Frictional force is 0.2 mg. Substitute in the first equation, done. You can leave it as a fraction. You can write it as a decimal here, 0.2. If by the same way, if you simplify, 3 simplified with 3, so the frictional force is equal to 0.6 mg. Substitute in this equation up. Now, mass is 3, don't forget, so will be 3 mg sine alpha is 0.8 minus tension minus frictional force found 0.6 mg is equal to ma. Now m is 3m. Don't forget this, as I forgot here. Now we have two equations. Look at this equation in terms of T and A, and this equation also in terms of T and A. By solving or get the equation of the system by adding these two equations, you will remove tension and tension. You can get the acceleration, then substitute to get the tension. Or if you want to get the tension direct, you can use elimination method. You can divide to remove m with m. Let me write the equations again here. T minus 0.2 mg is equal to ma. Second equation, when you write 3 times 0.8 will be 2.4 mg minus tension minus 0.6 mg is equal to 3 ma. By solving this system of equation by using elimination, if you add, you will get acceleration first. If you want to get tension first, you can divide both and remove a with a, m, you can solve the equation to get t. Because he asked to get t directly, you can use long division, you can use division. I will write it like this, t minus 0.2 mg divided by 2.4 m minus 0.6 m, 2.4 minus 0.6, so the answer is 1.8 mg minus tension is equal to, when you divide, remove a with a, m with m, so will be 1/3. Use cross multiplication, 3t minus 3 times 0.2 will be 0.6 mg is equal to 1.8 mg minus t. Collected 2 in one term will be 4t is equal 1.8 mg plus 0.6 mg. Simplify and to get t. 1.8 plus 0.6, so the answer is 2.4 mg, then divided by 4, so the answer 3/5. T is equal 3/5 mg. This is the exact value of the tension. In terms of m, you can substitute g, 3 times 9.8, so the answer will be 5.88 m. This is in terms of m. Or you can find the acceleration by adding, then substitute in any equation to get the tension. Look at part A, find what? Find the tension in the string, done. In part B, state where in your working you have used the fact that the string is modeled as being a light. Using a light tension, this means a constant tension throughout the string. So use same value of T through the whole string. Part B, find the magnitude of the force exerted on the pulley by the string. In each time when I ask it to get the resultant of the forces exerted on the pulley, I will take this part to show that exactly how to show your work out. In case if we have a pulley and we have two tension and both sides are same, so where is the resultant of these forces will be like this. Resultant of the forces exerted on the pulley is T and T, and you have to find the measure of this angle. In general, resultant of the forces exerted on the pulley is 2T cosine theta over 2. Use this form. So 2 and the T found, which is 3/5 mg. Cosine angle in between, it's given here down, the angle alpha, we already have it, but this will be 180 minus alpha. So it's given tan alpha is equal to 4/3. Tan alpha is equal 4/3. You can find the angle tan alpha 4/3. This answer will be 53.1, 53.1. But the angle up is 180 minus this answer. So 180 minus the answer will be 180 minus 53.1. So the answer is 126.9. So to get the resultant will be cosine this angle divided by 2. When you divided it by 2, so the answer is 63.45. So to get the resultant will be 2 times 3/5, 3/5 times 9.8 times cosine 63.45. Your answer will be 5.256 in terms of M. This is the resultant of the forces exerted on the pulley in terms of M. You can round your answer. You can try to get it exact if you'd like to get it exact. He asked to find the magnitude of the force exerted on the pulley by the string. If I ask about the direction, exactly bisect the angle between these two forces. This is the final answer. Thank you.